I'm so excited to have Mike here. Mike is it's a legend in the supply chain world. I was super excited and looking forward to this conversation. So Mike, thank you for doing this. Super happy to have you on here today.
Yeah, thanks for inviting me. I was excited to get the invite.
Hey, I couldn't help but notice that you have quite the robust training in academia, right? Before going into the industry, you literally got your PhD in management science. Tell me about that transition, right? From academia to real practice, right? In the real world, and back to academia in a way, right?
When I was an undergrad, I went to a small school and I was a math major. Back then data science didn't really exist. And so I want to take the stuff that I've learned and kind of apply it.
What was maybe a way to apply optimization and logistics in the early 2000s?
It was founded by a husband and wife team. It was David and Edith Simke-Levy. And David Simke-Levy was a professor at Northwestern at the time. He's now at MIT.
And are there any processes that even, 20 years later, you still use?
Learn that you have to make these trade-offs when you're building a product and building a company. Like, what are you going to do and what are you not going to do?
How did you think and how did this all come together?
And it was 2013. It was right when machine learning was starting to take off. Think about what your objective is and how you compare objectives.
I'm so excited to have Mike here. Mike is it's a legend in the supply chain world. I was super excited and looking forward to this conversation. So Mike, thank you for doing this. Super happy to have you on here today.
Yeah, thanks for inviting me. I was excited to get the invite.
Great. So, hey, I couldn't help but notice that you have quite the robust training in academia, right? Before going into the industry, you literally got your PhD in management science.
So I did. So
yeah, tell me about that transition, right? From academia to real practice, right? In the real world, and back to academia in a way, right? So yeah.
When I was an undergrad, I went to a small school and I was a math major. And I really liked the idea of taking math and data and applying it to problems. I think I had an operations research class in undergrad. I did the mathematical contest in modeling back then. Really liked the kind of problems that people were solving with that. And then, back then data science didn't really exist. And so kind of operations research was the area I was looking at. And, I was lucky enough to be able to get into Northwestern's Industrial Engineering Management Science program and went there for the PhD. I think I realized that I always liked industry, and kind of right after the PhD, I was in the market for looking at industry jobs. So that's kind of how I made the jump. I don't think I'd wrestled long with thinking like, I think I want a full academic career. It was more like, I want to take the stuff that I've learned and kind of apply it.
That's fantastic. And so, you eventually made your work to Logic Tools, right? Company that helps design supply chains.
I did. So I, right out of graduate school, I went to work for IBM Consulting, and I was there for about 18 months or so. And I think there was a lot of travel, and so the wear and tear wasn't great. And so I joined Logic Tools. And when I joined, there was about 5 people there, and it was a pretty small company. And basically, everyone I talked to ask for advice, like, should I join this company? When I described it, I'm like, well, it's 5 people. There's not much revenue. Product's a little rough. Everyone said no. It was probably the right advice to give, but I did it anyway, and it was just a fantastic experience.
So what from your academic upbringing, right, did you bring into Logic Tools? What was maybe a way to apply optimization and logistics in the early 2000s?
Yeah, so when I joined, I think the reason that I was pulled to Logic Tools, it had an academic founding. So it was founded by a husband and wife team. It was David and Edith Simke-Levy. And David Simke-Levy was a professor at Northwestern at the time. He's now at MIT. And so I knew it had a rigorous background, and they were doing, good optimization work. And also when I was in grad school, I really liked Mark Daskin's classes when he was talking about facility location problems. And this was what Logic Tools was doing at the time. And I wanted to dive in and kind of apply that knowledge there. I wasn't writing the algorithms. That wasn't really my role. My role was kind of in the middle. I was talking to the people who were writing the algorithms and then talking to the market and trying to bring in customers and make customers happy. And so it was a fun role where I was seeing the optimization, had input into sort of what things we should do. And then on the other side, talking to clients and seeing how they were using it and how to best train them. So yeah, that was kind of what sort of pushed me into it and the role that I took.
And are there any processes that even, 20 years later, do you still use?
Like many, I learned a lot there. I'm not really a product manager, but I got to feel what it's like to build a product and sort of see how that works. And one of the strategic decisions that we had to make is we had to make a decision. Should we have lots of features or ease of use? And there's some trade-off there, no matter how you cut it. If you work really hard, you can get features in that are easy to use, but it's still hard, and there's still a hard trade-off. And we went with the ease of use, and it was interesting because we had to cut out features. And I think the other interesting thing is that the market says they like ease of use, but we had to fill out tons of RFPs, and the RFPs always
Right.
had some question like, "Do you have this obscure feature?" And if you answered no, you knew you were losing points, and you had sort of lost you're decreasing your chance of winning a deal. So it was a very delicate trade-off, and I kind of learned that you have to make these trade-offs when you're building a product and building a company. Like, what are you going to do, and what are you not going to do? Where are you willing to lose and not lose? And it's not easy, and it never got easier, but it was sort of fun to see that and kind of live through it, and live through the repercussions too. Like,
Yeah.
if you skipped a feature, do you make it up or not make it up?
Now, speaking of company building, right? You have obviously founded a very successful company. I was reading through your fantastic Substack, which, by the way, I recommend everyone listening into that you should really look at Mike's Substack.
Oh, thank you.
And I read your four-part series about Opex Analytics, right? It's a startup that you eventually sold to LLamasoft. You described it as a mix between consulting and software and a product. Really resonates, right, to problems of optimization. So, yeah, tell me about Opex Analytics, and more specifically, what's that balance there, right, between cookie cutter solutions, optimization, kind of like a little bit about consulting, a little bit about product. How did you
Yeah.
think and how this all come together?
Yeah. So I guess the story started, back in Logic Tools. I got to see a startup, and I got to see it, rise in size. So by the time we sold ourselves to iLog, we were about 45 people. And then I learned a lot. The iLog team that bought us, that was the Cplex group. And so I learned a lot about their business model. Then IBM bought them, and I learned about their business model. And I bring that up because I think it was, this network and all this learning kind of helped us build Opex Analytics. Like, it was like, that was sort of some of the background. And then, I'd like to think there was some grand plan, but in the end, it was like I wanted to do a company on my own. Like, I wanted to do a startup, and we had some people that kind of wanted to get in it together, and we were trying to figure out, like, what are we going to do? And it was 2013, and it was right when machine learning was starting to take off. So if you remember back then, it was like machine learning was just starting to take off, and we thought there was this great opportunity because companies were kind of interested in it, but had no idea how to do it. And we thought, let's build a company that can take those skills and use them, sell those skills to other companies. And I just did a talk at Purdue University, and the
Right.
students were asking me some questions about a startup, and one of them was like, "Well,
Okay.
did you do a marketing analysis and a plan on the consulting versus the software?"
I'm sure
I'm
I
like,
know
I
the
wish
answer
you
to
could have
this
said
one.
that, but the day we signed the paperwork to sort of be all in and sort of start the company, I think the co-founder and me got in a fight. Ganesh Ramakrishna and I got in a big fight whether we were going to be a software or consulting company, and it was a kind of a bitter fight right at
Yeah.
the beginning. And we were good enough friends that we said, well, we're just going to put that beside and start the company anyway, not knowing which of the two directions we were going to go. So we sort of just started the company, and we were going to see how it went and see what direction it took.
And so, if you could describe what your customers really valued, enjoyed, liked about Opex, what would that be?
Yeah, so I think what we did we did really well is we brought together a team of people who really understood the algorithms of what was going on with the machine learning movement, and how that could impact a company. Because companies were trying to figure out, like, what does this mean? They were reading about it too in the press, and they knew they had to do something. Because remember, competing on analytics from Davenport was out, like, it had been out that a while. So companies knew they needed to do something, didn't know how to do it. And one of our advantages, we could bring in the talent of people that knew how to do it. And we also had the business side of us that said, okay, let's not just do this for fun, but let's actually apply it to inside companies. So that was kind of one aspect of it. We worked really hard to build a really solid team that knew the algorithms. Kind of the other niche we did too is early on, we also brought in optimization. So our background was optimization, and we brought in
Yeah, yeah.
optimization people, which, it sounds obvious now, but in 2013, 2014, 2015, people were not looking for optimization. Optimization was sort of old technology, kind of boring. But we realized that, like, this is how you also solve problems. And so we could actually come in with the whole suite. And we ended up competing with lots of companies that were either focused on one or the other, just an optimization shop or just machine learning people. And we found with both of those sides of the house, we could come up with better solutions. And then on top of that, we're like consulting or software. We wanted our solutions to have an impact and have some leave behind. And so we very early on started building software solutions for our customers. So kind of building custom solutions that either they maintained or we maintained. And as we matured through the years, we got closer and closer to kind of off the shelf ish type of
Right.
products that we were offering.
I
Yeah.
want to.
So
No,
that's go ahead.
I want to go deeper on that off-the-shelf concept that you just mentioned, right? Because one thing that surprised me was the variety of clients that you guys worked with, right? What sort of, or were there any sort of conducts or principles that all machine learning optimization customers projects took on? Was there any layer of commonality across them that would make it into, a product or like off the shelf, as you mentioned?
Yeah, so the thing that we stripped away early on was like, let's keep the algorithm. The algorithms could be very tailored to a company, but the interface that the companies interacted with did not have to be off the shelf. And so we early on built a platform product that helped us deploy. We weren't selling it commercially early on. We were just using this so we didn't have to rewrite connections to databases. We didn't have to rewrite a user interface. We'd have to configure it, but not rewrite it. So we had a team that was building that particular product, and that product matured over time. So we were able to offer, not have to build everything from the ground up, and that was helpful. The other thing that we did or tried to do, we weren't great at it. Like if you're a custom shop, I suspect anyone who's doing this custom, at some point we looked at the organization, we're like,
Right.
I think we've built 50 different forecasting engines. And so, we looked and said, can we consolidate this somehow, get this knowledge all together? And it's harder than you think. Like, even when you're running the company, it's like harder to sort of corral all these different pieces to come together and sort of make an off-the-shelf product. Once you've already sort of been a more custom kind of place. And so, but we tried some of that stuff too. Like, all right, let's try to build some engines here that we can then sell, the next time without having to build it again.
Yeah, I want to also explore maybe your favorite project, your most successful one. Whatever you want to tell us, what was that?
So one of my favorite ones was we worked with a company that sold like a very commodity item, and they had very good data on sort of all the bids and what they won and lost. And what I like about this one is it just fit exactly the spirit of what we did, because our competitors were all focused on only the machine learning aspect of it. Can we predict what price we should
Right.
offer this product? And given that price, what's our probability of winning? So we understood that part of it too. Like there's a big element there. But what I really liked is that since we had this optimization side to us, we realized that predicting the price is only one part of it. If there's,
Right.
capacity in your manufacturing, capacity in transportation, and transportation cost, there's a nice optimization problem that marries together. So like, for example, if you've ended up selling a lot early in a season, then you're sort of running out of capacity, and then you probably want to go with higher prices later in the season
Right.
because you just don't have the ability to manage that. And conversely, true, if you're not selling much, like they'll lower your prices and fill up your capacity. So that was kind of fun because it highlighted our sort of the power of ML plus optimization together. And it's like one that I think of, like I'm really proud that, like, all right, this is how you bring this technology together. It doesn't stand alone. These algorithms don't just stand alone. They have to work in a system to solve a problem.
And I totally agree. And also, there's this tendency to think of them as separate things, and the more creative folks like you that have started companies that try to solve problems, mix them together, right? You even have a post in your Substack, again I highly recommend, reflecting on Opex. You wrote that data science doesn't really equate with optimization, right? And you're going into this a little bit right now, right? Like you have ML, you have optimization, you have data science, and there are sort of distinct career paths or disciplines, right?
They're distinct, and they have their own characteristics, and we have the same problem with AI right now, is that it was just these weird umbrella terms would kind of pop up, and then certain techniques would sort of win the day. And by keeping focused on like telling everyone like under the hood there's all these different things that you can do. You can analyze data and just use it to build dashboards, or you can start applying some algorithms, and we have prediction algorithms and these algorithms that make decisions. So there was actually a lot of education on like the class of optimization algorithms that actually made a decision. Like you just need this part of your system to sort of take it to that next level and sort of help you automate the actual decision rather than just making some prediction. And it was at the time, maybe it's even still true today, is like it was hard to convince people of that. Like everything you read, like if you picked up a book at the time on analytics, it almost never mentioned optimization, like almost never, and maybe it did in passing. So that was that battle we were trying to fight.
I have this theory lately that now a very desired skill, right, in an age where pretty much building a model, even optimization model, machine learning model, or using advanced analytics, has the barrier to entry for that has been dramatically reduced because of the large language models being very good at creating models themselves.
Right.
Then a very sought after skill that we will all have is being a good storyteller, right? Being able to tell a good story using data and making it all come together. So you just mentioned that you had to play that angle of convincing people to, hey, you can use these two disciplines together. Tell us a little bit about that. How are you good? You are definitely a great storyteller, right? You're right. How did you work on that muscle and that skill?
Yeah, early on, as we were sort of educating the market, one of the missing job roles in the whole analytics movement was what we ended up calling like a translator. And when I look back on it, I realized that I've spent my career as a translator. It's like someone who understands the algorithms, what they do, what they don't do in an honest way, and then someone who understands the business and what they want. And it's like you need these people in the middle to bring these two groups together, because you could see times when a business user would talk to a machine learning person and it just wouldn't work. It would be just a disaster. Like both sides would misunderstand each other and nothing would get built. And so we realized that there was this important role there. And then through Opex, we emphasized storytelling quite a lot. Like we worked hard to say, like, you've got to make your data come to life. You got to make the solution come to life. Mm-hmm. I've got some philosophy, like, I think I've had a couple posts on this, but I was,
Please tell.
early on, if you talk to anyone about storytelling, they go back to something like Pixar and like, you need this whole story, like, which is fine, but you don't always have the permission or the time to pull off something like that. And so I like to think about, business storytelling is a little different. And what I like to think about there is that you want very concrete examples. Like if you can, just have a little story that goes a lot longer. And that in my mind is storytelling, is being able to add those little things. You don't have to have the whole Pixar story of the arc with the hero and the problem and all that and the resolution. If you just have these little short stories that keep it interesting and make it concrete. Like for example, when even back in the Logic Tools days, I learned this early on, is that when you're demoing a product or showing a product, there's a temptation to sort of point to a field and say this does this and that does that. And I tried to spice it up every once in a while, like, oh, look at this feature over here. This came from our customer who had this problem, and this is why this feature is there. Just to make it more concrete instead of just a field on some screen.
Yeah, and also the fact that when you are selling to businessmen, right, like business women, business people, they're out to solve the problem, right? They're not out to purchase an algorithm, right? They're not out to purchase an optimization tool, right? They're out to solve a problem that they have. So yeah, someone like you needs to bring the bridge between the problem and what's technically feasible.
That's right. Yeah. Understand what are they trying to do and what's their objective, and then like have them visualize like, this is how an optimization algorithm could solve that particular problem, and here's what you would get, and then like here's what it might not do. Like you thought that like a common one I see is machine learning. Just the learning word got stuck in people's head, and like I tried to emphasize like
say more.
You need to keep feeding data. You need a mechanism for the algorithm to actually learn and get better. And let's talk about what that mechanism is. Like in your case, like, are you looking at quality control of potato chips? Like, what's the mechanism for getting more data into the algorithm and making sure the algorithm stays fresh? Like, all right, so we think about those things too.
Now, you obviously navigated this very successfully, right? Eventually, your company was sold to LLamasoft. You made your way to that team and eventually absorbed into the Coupa environment, right?
Correct.
Tell us a little bit about how that was, navigating the company from founding it to selling it. How was that? Maybe your biggest lessons about entrepreneurship and, completing that process.
Yeah, so it's for sure an interesting journey. And looking back, it was, the company like Opex Analytics, like we were in the right space. We had the right team of people. We had a lot of, machine learning experts. By the time LLamasoft approached us and said, we want to look at acquiring you, we were getting lots of, VCs, private equity companies, other companies were talking to us quite a bit at that point. And so it's almost like, you start a tech company, it's like this is one of the paths that's going to happen. Like if you're
Right.
doing, look like you're doing something successful in the market, like you'll get these kind of offers, and you have to sort of sort through that.
Right.
We ended up talking to LLamasoft, and it felt like a really good fit. It was a long conversation. I can't remember the timeline now, but there was, the initial reach out to maybe the first serious discussion was like a 6 month period, and then discussion started picking up from there. And it's kind of interesting as a founder to go through this because it's very time consuming. So it's very time consuming. Like
Okay.
if you decide to sort of pursue an offer, like it takes just a lot of time, and you're worried in the back of your head, like if this offer falls through, the business still has to keep going. Like,
Right.
we
Right.
can't let this slow us down. And then, emotionally, you have to be ready. Like it's kind of, we were a very transparent company, I thought, at Opex. We shared revenue numbers. We shared pretty much
Right.
everything we could share with our employee base. But this you have to keep top secret. Like you can't let it out. Like there's a legal ramifications. Although Lamasoft was private equity, so
Right.
but there was some of that, and you can't. It would be super distracting for the whole organization. So we wanted like to minimize the people that were distracted. So that was a process, and the other process you have to be ready for, I think, if you sell a company is just the legal side. Just
Okay.
yeah, like it's not easy. Like it's a long slog. There's lots of information, lots of stuff you
Right.
don't understand, lots of stuff that's really even hard to understand. I kind of wish we had ChatGPT back then, and I could type in like, "What the heck does this mean?" and just get some, just get some a second opinion because it's hard to even get second opinions. Like, you had to find other people that were, loosely connected to us who could keep a secret, and that we could ask questions to. Like, because even your own lawyers, it's sometimes, you're paying a lot for your lawyers. Even sometimes your own lawyers, it's hard to get a straight answer. Like, what does this mean, and what are the implications? And in the end, it's a pretty lonely decision. And you have to make a decision. Like, are we going to do this or not?
I was about to
And
ask about that, right? Like, why did you decide to sell, right? Especially in the context that you mentioned, you have VCs calling, customers calling. Why sell?
so it's a complicated question. And obviously, I've got a perspective because I'm right in the middle
Right.
of it. Um, we one thing I did, I saw Logic Tools get sold, and I saw how that worked, and I didn't have bad feelings about that. I thought, okay, this is how this is going to work, and I understood at Logic Tools like the idea of handing over the keys, and so I knew that was coming. Like it's a thing, and I looked at all the people after Logic Tools. They're all doing fine. They all had great careers.
Right.
So
Right.
it's possible to do because there's a huge emotional thing of having the
Of
keys
course.
to the company, right? We
Of
had
course.
no VC money. We were all bootstrapped, and so we were, it was ours. And a couple things that kind of weighed into the decision as we thought about it. We ended up spreading the equity in Opex quite widely throughout the employee base, so lots of people had equity. So we weren't making a decision just for us; we were making a decision for lots of people, and so that kind of factored into it. And I always think too, you have to be a little humble too. Like we made it to the 120, 140 when we sold people mark. And there's this kind of famous number, and I don't know, sociology or something like the Dunbar number or
Yeah,
something
yeah.
like 120. And
120.
things change. Like if you have 120 people in a company, you can know everyone. Like you can sort of know everyone, and everyone knows everyone else. And then after that, you don't. And the side of us too was like, well, what if we mess this up? Like there was no guarantee that we could just keep growing. Like we might make a mistake. So we had to consider that, and we really liked Lamasoft. Like Lamasoft and TPG really wanted us to be part of the family. We saw where we fit there, and so in the end, some lonely night, we had to sort of make
Sure.
the final decision. Like this is what we're doing.
Hey, to wrap up this topic here, maybe your two, three biggest lessons as a founder, successful founder, going through the whole motion from start to selling.
So one of my big lessons, and I learned this at Logic Tools, and I give this if any founder ever talks to me, it's like the first piece of advice I give is like, you really have to worry about sales, like sales, 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 and technical founders and people who like optimization. It's not really your first instinct, but you have to be the one that's out there pushing that. And it's not so easy just to hire just a salesperson, especially early
Right.
on when the product's not well defined and it's not
Right.
well defined what your mission is. It has to be you out there because you get such good feedback when you're interacting with the market. And so that was one lesson. It's just like think about selling. The other lesson is the one funny one I learned. So
Yeah.
Logic Tools is a software company, And then, iLog, IBM, 100% software. On Opex, we had a lot of consulting. And I learned that how much easier it was to sell consulting services and software. I'm not sure if it's true, but
Okay.
I remember days at IBM and iLog and Logic Tools, you'd work really, 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 really hard for like a $50,000 deal. And it was like pulling
Right.
teeth and all this other problems. And at Opex early on, I put some proposals in front of clients, be like, I was kind of nervous. I'm like, I think this will be $450,000. They're like, all right, where do we sign? I'm like, oh, that was kind of easy. I wasn't expecting that. So that was an interesting lesson that I
Yeah.
learned. Like I don't know, I don't know if it's still true in the market. And then I think we focused a lot on the people and the culture. So we worked really hard on bringing in good people. And that's easier said than done in the sense that if you're bootstrapped, like you're bringing in people before you have projects and ways to pay for those
Right.
people. And so there's some rolling of the dice. Like one of the things we were doing, we were hiring right out of a couple of great master's programs in machine learning, and those students graduate when they graduate, not when our
Right.
cash flow is optimal. And so
Right.
it's like, do you take them or not take them? And so we had to wrestle with those kinds of decisions too.
Thank you. So, all right, let's switch gears here. You've been teaching optimization at Northwestern for, I think, over 25 years now. Have you noticed any patterns in students? One thing that you see students really struggle with regarding optimization.
Yeah, so I've had a complicated teaching career. So
Okay.
I was an adjunct forever. So all through my whole basically professional career, I was an adjunct teaching a couple different classes. And then just in the last 2 years, I've joined full time, and so I've got to see sort of both sides of it. The optimization class I taught was in the machine learning program. So credit to Northwestern's machine learning program here, where they had an optimization. It was required, then it became elective. It sort of bounced back and forth, but I had the majority of that class go through there. And I thought what fascinated me about sort of watching that evolution is that people who were interested in machine learning and data science basically had zero idea that anything like linear programming even existed. And so it's actually been very fun to teach that cohort of students, like, this is what linear programming is, here's how it works, here's why you need to know about it, because some problems will need this.
Right.
And I think early on, everyone in the optimization space saw this. It's like someone at some point would write some machine learning algorithm that solved the traveling salesman problem, and all us optimization people are like, I think we know how to do that one.
Right,
It's been
right.
solved. So this was kind of an interesting take, or interesting to see, like, just how much room there is for optimization still in the world. Like, the machine learning algorithms are still way more popular with the general population.
It's kind of interesting, right? Because you've been talking about this and with Opex, right? That you've been basically talking about this for 20 years or so, right? That, hey, it's the mixture of these two, maybe different skills or different career tracks where the value is, right? So yeah,
Right.
I find it fascinating that you're still talking about that 25 years later, right?
No, right. It feels like, well, I'll spend the rest of my career talking about it. I think the algorithms on the machine learning side, it just somehow seem cooler or do more things, and especially with LLMs and deep learning now, it's like, it's even hard to get a word in. It's like, oh, this stuff is taking all the oxygen out of the room, and we still need to keep pushing the fact that optimization exists, and we need to use it.
For sure, for sure. And yeah, so as part of your teaching activities, or as a part of like a side project, I don't know how you call it, you have a very popular Substack on optimization, on your teaching career, on your entrepreneurship lessons. So yeah, tell us first a little bit about why you started writing so much.
Yeah, so I think I've always kind of enjoyed writing. I had a couple blogs along the way at Opex and even before at IBM, and it felt like a good way to get the word out. And then for sure, I wanted to, when I eventually left Coupa, I wanted to sort of share what I knew, just like share everything. And I enjoy writing the posts; they're very fun to write. And it just it feels like a good sort of artistic outlet for
Right.
someone in a technical space. It's like, oh, let's share this bit of information, and did it up on Substack. I was doing it on LinkedIn, and then I kind of wanted to own the content more, have a little more control, and just be able to search easier. And I thought LinkedIn wasn't exactly set up for that, so post it up there first, then share on LinkedIn. But just totally enjoy it, and it's one of those things that's counterintuitive, but the more you write, the more ideas you have for other things to write.
100%, right?
Yeah, it's like,
Like what I enjoy about this conversation is, well, you are the ultimate storyteller, right? And you write it, and you bring the gap, and you bridge those gaps, and you can identify what's valuable or not. I want to talk about a specific post that you wrote, 5 hot takes from your supply chain class, opinions that might get you in trouble, right? So I will say the hot take and you'll walk us through it, right?
Okay, yeah.
First one, optimization isn't that valuable in multi-echelon inventory optimization.
Okay. This is one of my hotter takes.
Yeah.
I've talked about this before. So I was right at the heart of the multi-echelon inventory optimization movement. Like Logic Tools was doing it. We built a multi-echelon inventory tool. I saw it in action. I saw how companies wanted it in their RFPs, talked about it, and thought about it. But as I kept watching companies use it and think about it, it was like they really weren't using the optimization part. They were more using the multi-echelon part. So there is value in looking at inventory across your echelons, but what you're optimizing wasn't always clear. It sounds great to say optimization in a product, but what you're optimizing, which was actually the committed service time from one node to another, it didn't feel to me like it was that hard of a problem in that there weren't that many choices. Like, okay, there's a couple supply chains that are really long and complicated, but if you're just, making a beverage, like your supply chain is pretty simple. And the insight of multi-objective optimization is like, should you store more raw material or more finished goods?
Right.
And then it's like, well, you just have two choices there. You don't really need an optimization engine to do that. So that was kind of the gist of it. It almost fits with Ely Goldrat's famous book, The Goal. I think he wrote that book to help companies, to help sell software. That was his original use of the book.
Okay.
And it turned out that people just took the ideas. They didn't need software. They just took the ideas and implemented them. I think the same thing is true of multi-echelon inventory optimizations. Like the optimization it's cool to bring up, but you don't need it. Like, all you need is the insight. And the insight is like, all right, let's store more raw material so that we can have less finished goods. Like, all right, there we go. We don't need an engine to tell us that.
Okay.
So yeah, that's a hot take. Let me give you the background on the hot takes.
Please.
So I'm teaching these students, and and I've got a network of people who do this stuff for a living.
Right.
I wanted to send these students out to my network and have them work, and I wanted to send them, like I couldn't send them out there like. And if my friends came back to me and says, why doesn't this person know that? Like, I gotta tell them this. They have to know this. And some of the stuff I told them is like, you're not allowed to say this, like multi-objective optimization. I told them they're not allowed to tell people they believe this until they're well into their career because they'll get in trouble. I'm allowed to get in trouble, not them.
Right.
So yeah, that's where it came from.
I see. Second one, and this is maybe my favorite one or the hottest take. Second hot take: don't worry about the assumption of a normal distribution in inventory models.
Okay. So yes, this one gets me in trouble too.
Of course.
Yeah. So here's where this came from. My thought on this one was that I saw a lot of inventory models get implemented, and they have the normal solution. And what I saw was that there were hundreds of basically estimations going into everything.
Yes.
Just figuring out what lead time is and lead time variability, and sometimes just demand and what the forecast error and what number you're going to use and how you're going to incorporate bias. Like there was all these kind of assumptions that were already built in, and in the end, I kind of felt like just having a process for managing the inventory that was somewhat reasonable was like 90% of the value. And it kind of bugged me when, someone would sort of bring up like, we can't implement this. It doesn't have the normal distribution. Because once you get away from normal, it gets really complicated.
Right.
And someone would say like, it doesn't have the normal distribution, so I'm going to not use it. And I was thinking like, we don't even know what lead times are. Like, I'm not sure why we can't be that worried about the normal distribution yet. Like, we can worry about that, but let's worry about that 5 years down the road when everything else is looking sharp. I mean, other people can disagree, like that, but this is my hot take.
I certainly do, but hey, this is fantastic.
Yeah, no,
I get your point. I
get
get your point. I get your point.
Yeah. And, the other thing is like, for sure there are cases where, a non-normal would be better, but my general point is like, yeah, make that fifth on your list.
Number 3, I don't like solving the vehicle routing problem with a direct intergroup program, right? It has to do with the travel and salesman problem. Yeah, a little bit of context here in the hot take as well, please.
Yeah. So vehicle routing, how do you route your vehicles? There's actual mixed integer programs that you can use that basically have a variable for this vehicle should go from this point to that point. And what I think about VRP is that our vehicle routing is that it just gets complicated really fast, even for simple problems. There's, time windows is a big one. Driver rest rules is another big one. And, what we found just building implementations of this is that it was almost better to have a algorithm that enumerates possible feasible routes and then feed that into just like a set covering kind of model to solve and figure out which routes you're going to take. Like, it felt like that was a more honest approach and an easier approach to get your head around, because as soon as you start adding these other constraints, your mixed integer program gets out of hand very fast. And and even at Logic Tools, I think I learned this, and I saw it at Opex too. It's like, no matter what you think the specs are right now, they will for sure be different as soon as you hit the first run button and learn what the real specs are. And so you need a flexible mechanism to get these things solved and to keep enhancing them.
All right, number 4, the classic academic facility location models aren't that special. So yeah, again, context and
Yeah,
context.
it's context. So I spent my career, network design, so I know that space really well. I have a book on supply chain network design, and there's general, that book sort of highlighted sort of general facility location models. And we look at the academic literature. There's like set covering models and p median models, and these all have specialized algorithms that solve them, but which were important like 25 years ago when engines like Garobi weren't like super fast.
Right.
And my feeling now is that, if you look at some of those models, they can basically be modeled with any off-the-shelf network design tool. You just, turn on and off a couple different variables, don't add some data in some spots, and then run and get the answer. And so I like to, when I taught that, I taught, here's the classic academic models. Let's map them to, what a commercial software would do, and show you
Right.
that you can solve them. Because I wanted to show the students that, like, when you run into a facility location model, probably a commercial solver is going to be able to handle it. You just might have to be creative in how you set it up, and set up the data in some way, or
Right.
deactivate and unactivate some objectives. But otherwise, like, you can solve it.
Number 5, avoid inventory models with a cost of lost sale or back order cost.
Yeah, so the inventory literature is full of hundreds and hundreds of different inventory models and all kinds of variations. And back order costs and lost sales look interesting. My experience, again, kind of going back, is maybe I haven't worked with super sophisticated inventory companies, but I've worked with some big Fortune 500 companies, and it
Right.
was like estimating those lost sales or getting people to understand it didn't make intuitive sense, because I know what they're doing. Like, the news vendor model basically has a lost sale in there, and it's sort of, but when you set that number and then set the value, the profit that you get, it's basically implying some kind of fill rate or service level that you're going to offer. And I just felt like the fill rate was just much more intuitive. Like, like a business person can understand, like, I want a 99% fill rate. I'm like, all right, 99% fill rate. Here's how much inventory you have. Is that good or bad? And they're like, oh, okay, maybe it's 95 is what I want. But it felt like a better question than, like, do you lose $1 or you lose $2 when you don't sell this thing? Because, in the real world, there's like weird substitution effects. There's all kinds of other
Right.
things that go on that just make that complicated. Not to say you should never use it, but it also felt like I wanted to point my students in the right direction. Like, all right, if you just, kind of ignore that at first when you're starting your career, like, you're going to get 80% of the way there. And maybe once you understand that really well, then you can start adding some more things to it.
Fantastic. So, Mike, a couple, or well, 2 to 3 rapid fire questions to start wrapping this one up.
All right.
First one is your tips on becoming a great storyteller like you.
Yeah. So I would,
On the
I don't
data
know.
and optimization realm, right?
Yeah, I don't know. I mean, my big tip would be, like, start writing, see what works for you,
Okay.
find your own voice. Like, I feel like I've kind of found my own voice. Don't try to be someone you're not. So that would be kind of one, and then just kind of be curious about both the business side and the technology side, like, and go from there. But yeah, I'm not sure I have secrets beyond that.
All right, second question. What's the biggest thing that you've learned from your students?
Um, Gosh, I mean, I learned a ton. Like, I had a taught my supply chain class for the first time in the fall, and I knew the students because I did a capstone class with them, and so I knew they were pretty bright. And so I was like, all right, let's make sure that I give these students, enough to work on. And so, I think I learned that, I'm pretty optimistic about this next generation. I mean, that's the thing that I learned, is that I saw lots of talented students who really wanted to learn and dig in and ask pretty deep questions about some of the things. And so I think that was kind of fun to see. Like, I'm for sure, as optimistic as I've ever been about sort of the next generation. Like, you read some things like that may be more pessimistic and things like that, and I sort of saw the opposite.
All right. What are your favorite / most exciting technologies or movements that you're seeing in this space right now?
Well, of course, everyone has to say, like, the LLMs and all that, and so, and I teach on that, and I was just talking to a student. We had a long conversation about LLMs and how they're going to impact the education market. Like, so that's for sure interesting. But I think everyone thinks that. Like, so I'm in that camp too, thinking that thing's interesting. But I think some of the breakthroughs in optimization are still going to come. And as these optimization tools get more and more powerful, what I'm excited to see is like how these things can get deployed more frequently. I think there's been some breakthroughs in how linear programs are formulated that take advantage of GPUs to solve the programs faster, and that's going to be fun to watch that technology roll out and see this capability still get better and better. So I'm kind of excited about that. Like that'll be the niche one for your audience, I think. Like that gets me excited just seeing solver speed increase and what we can do differently.
Final question, the one that I like to ask all of our guests at the very end, is what recommendation or tip do you give operators to find a quick efficiency or optimization opportunity? Where should they look?
So it's any time you find yourself making a trade-off, and there's probably more trade-offs than you think that exist. Like there's an opportunity for some kind of optimization engine or some kind of heuristic in there to sort of make that decision. And the other one I would give too is that if you're having a hard time figuring this out, like I think the framework for how we set up linear programs is very helpful. Is like think about what your objective is and how you compare objectives. Like if you change something, how do you know you did it better? And then think about what levers do you have, what decision variables. Like if you think about that, like from an operator's point of view, you might uncover some other opportunities in your organization to apply optimization to automate or solve some problem that you hadn't been able to solve before.
Mike, thank you so much for being with us today. I really enjoyed this conversation. Really, great to see someone bring these very hard, complex topics and try to make it explainable for the rest of the world, and to witness the power of the optimization and these other tools. Thank you very much for being here with us today.
All right, thanks, Diego. I love your podcast, so keep it up.